And this part is all truth. Yeah, so I'm actually honored and humbled to be here to talk about my friend and my colleague, Doug. I am going to focus a little bit of background. You know, I met Doug probably at an early ACI in the late 90s. I actually got my master's in '86. Went into Peace Corps, did some consulting, came back, got my PhD. '95, was hired at Michigan Tech as a freshly minted but old assistant professor. And that's where I met Larry Sutter, and we started working together a lot. And we were in the process of how we're going to beat Purdue, Illinois, Minnesota, all the big schools seeking national level concrete. And so what we decided to do over a few libations is bring in a ringer. And the ringer we brought in was Doug. We figured. I thought it was the lady in yellow. Remember that? That was ACI, I think, San Antonio, right? Yeah. So I still remember a few things. Anyway, we had this is how we started partnering together on a lot of work. And without exaggeration, my career trajectory was based on my association with Doug Hooton, and both as a colleague and a friend. So, Doug, I'm not going to honor you, but I will say thank you very much. I'll just start, climate change is not going away. We have some slight political changes that have occurred in the United States. But we know that, and I don't know why my formats got messed up, doesn't matter. Bottom line is we know that this is going to continue. Administrations will change. This will remain relevant. And this is data that is from NOAA. This shows ice core data going back 400,000 years, and this just shows what CO2 in the atmosphere is doing. So forget about models, forget about measuring, forget about polar bears dying. This is where CO2 is going, and this is data from NOAA. They're still actually haven't ripped this website down. They will, I'm almost certain. But you can see that trajectory, and as of a few days ago, we're at 428.37 parts per million CO2 in the atmosphere in Hawaii. This continues to move upward, and it motivates us. And so I was back a little bit. Larry and Doug were fishing, July in Ontario, and they came to the realization of the connection between carbon dioxide in the atmosphere and global warming, and they thought we need to use more clinker. We got to warm up the environment. And then they realized, we need to actually reduce CO2 in the atmosphere. And we know it matters because Doug ran the numbers, and this is in his seismic testing lab. He realizes if an earthquake hits, he's going to die in his office. and so basically, for about almost 1.5 cubic meters of concrete is used per person on the planet per year. Civilization, as we know it, is built with concrete. That's not a joke. Every single thing that makes modern civilization possible is based on concrete, but the impact is large, and in the United States, roughly 1% of our CO2 is linked to manufacturing of cement. That's because we buy it from Canada. But worldwide, it's about 5 to 8%, so it's really, really critical that we get a handle on this. And where's it coming from? Simply put, it's coming from basically the making of clinker. Roughly 90%, 89, 87% of our CO2 associated with a cubic yard or cubic meter of concrete in the truck at the gate is from the manufacture of clinker. And so, recapping, we create Portland cement by burning rocks. The rocks we are burning, we use fossil fuel to burn them. And in that cubic yard or cubic meter of concrete in the truck, 37% of the greenhouse gases associated with that are from the fuel used to make the clinker. But the main rock we're burning is limestone. And we're driving CO2 off, and that roughly 50% of that CO2 in that clinker is from those reactions of reducing calcium carbonate to calcium oxide and CO2. So that's the big dog that we got to deal with. In the U.S. right now, our numbers are about 0.922 kilograms CO2 equivalent per metric ton. So that's where we're at, and we need to drive those numbers down. Now, there are carbon reduction strategies. Multiple people have published them. This is some shameless self-promotion. There's a new AASHTO guide on this, at least right now. This came out in February, and this guide was available for free. It was developed by Federal Highways, but then AASHTO took it over, so now you got to pay for it. But the bottom line is there's strategies listed in here and calculations, and basically, again, a eureka moment for many. See Doug hard at work in the lab, but basically we got to optimize our cement, and we got to optimize our concrete. And we've heard a little bit about that already this morning. The big deal here is getting clinker out of concrete. Very, very simple thing to do, right? Except we run into, I love when I see presentations and people talk about the strength. Oh, I did this crazy thing and I'm still getting the same strength. Yeah, but I can't work with it. I can't place it. It's going to cause my rebar to corrode and whatever. So basically, when we take the clinker out, as was discussed, we're taking the heat out. And as we start to take heat out, it starts to pose those problems in cold weather. And Henry talked about that. So a big deal is, yeah, if it's warm, that slag's going to kick up. If it's cold, it can lay there. The other thing is we have issues with finishing. We're cutting back, we're using finer particles. You saw that in the last talk about the blade fineness. As that happens, we're getting less bleed water, hitting the surface, and not only rate-wise, but even volume-wise. And then the slower hydration is going to affect when we can joint saw, when we can strip forms, when we can drill in dowel bars, when we can move the process forward. So, and then the final thing is less cementitious materials, as we take them out, means moisture control becomes that much more problem. And that's what's happening. People are not changing their aggregate moisture contents and whatnot, so we're running into issues. So I'm going to now talk about some work that I've been doing with Doug over the last 5 years or so. So one of them, we got funded by Breakthrough Energy Foundation. We became known as the Barriers Group, especially when they started getting to know Doug. Basically, and it's kind of funny because then we became really popular. We were also technical people talking with policy people about concrete, right? The policy people are always setting policy. We were brought in to help them understand the barriers that exist within our market and how technically we can address these. And we became super popular with like all these foundations, government people. It was unbelievable. We felt really kind of like rock stars. In the end, what we found is a lot of our thought was going to be specification barriers, but where we found the barriers are risk. Risk to the owners, risk to the contractors. And so basically, it was a very important contribution was concrete technologists communicating with these policy people and moving things forward. We got another phase. Doug was happy. He's celebrating. You know, there's a lot in this picture. This could be 20 minutes right here to talk about that picture. But the bottom line is we started directly engaging with a group called the Hyperscalers. This is a consortium of data center owners, and we started demonstrating low embodied carbon on some projects. And one of them was a tilt-up demonstration. This, we actually full-scale construction of tilt-up panels using 3 different mixes. And you can see we had a control mix, which was a type 1L cement. We had another one with the slag cement, and we had a C1157. I can't talk about it, but you can imagine, since we're talking in this session, what might be in that 1157. Bottom line is we saw some fairly dramatic reduction below benchmarks from 12% just for the control all the way to a 58% reduction. And we did a lot of lab work. I know we're pressed for time, it's published, but we found through the lab work, we knew that high clinker reduction mix was going to have some issues, both with placement and finishing, and then also with the bleed. And then the hydration curves definitely indicated cold temperatures would be a problem. Well, no problem, we went out on the site, it was 28 degrees Fahrenheit, not centigrade. So we had a problem, right? They had to blow the ice off the forms, blow the ice off the rebar. Went ahead, built it, standard construction. Everything could pump, everything could be placed, everything could be finished, except the finishing crew almost walked off the job with that mix 3. I mean, it was really difficult to finish. we discussed match curing as a good idea. In the U.S., it's pretty rare to use match curing, pretty rare. And what a recommendation that came out of this work is you folks need to be looking at match curing. And we were able to tilt even mix 1 and 2 at 3 days. But mix 3, we had to wait, maturity was telling us at 5 days. They finally lifted it at 7 with no problem, or tilted it. So we really saw both good things and bad things, and we made some suggestions. It was published. We moved on to that with funding under ClimateWorks Foundation. Basically working with, we created RC3. It used to be the Reduced Carbon Concrete Consortium, but we have since rebranded since we were smart enough to realize political realities. We're just now about innovation, but this has been a really good thing. We worked with 39, we worked with about 30 states directly, developed a template that Larry Sutter actually took the lead on. Almost every state used it. Each state obtained about $32 million in funding. It was all online. Only 5 states got through, and the rest of the funding has been eliminated. So it's gone. Such is evaporation. But then we continued to work with the hyperscalers. The hyperscalers have supported us. This is AWS, Meta, Google, Microsoft, working with the Open Compute Foundation. And this time we did slab on grade, because slab on ground or hard troweled is the toughest of all construction. Don't kid yourself. Trying to get that troweled finish is an art form. And so we took that on and we built full, we took 4 mixes this time. You can see them again, a 1L, all the way through a slag cement, a fairly high slag cement at 40% replacement, or is it more? I think it's maybe higher, I don't want to do math. And then we moved to the 1157s. We saw some fairly dramatic reductions, up 60% off benchmark. So this crew, the hyperscalers are very excited by this. Summary of the laboratory work, again, we knew that those 1157 mixes were going to be tough to finish. They were going to have some issues, and we were able to inform on that, and then we built it. And we built it at our facility. We literally ripped out the middle of our floor in one of our annex buildings and pumped it, placed it, finished it, hard troweled it. And this has turned out really, really well. Takeaways, that 40% slag mix with the 1L, that mix rocked. The workers loved that mix the most. The finish on it was the best. And here, you hear slab guys routinely say, we need pure Portland mixes. And that mix, that is a nice stepping stone mix. So that's a standard mix now for these guys. We did have some problems with that 4. Again, took a lot of donuts to keep the crew from walking off the job, because that mix is really hard to place. In the end, the hardened properties, we did the abrasion testing using the European method. The 1157 mixes and even the slag mix are higher than the base mix. Great abrasion resistant, great properties. This has all been published. Lots of accolades. The White House came to our laboratory to do an announcement, and we wouldn't let them speak. So our understanding is, the first one, the tilt up, is part of an award. I was going to say, more feathers in Barb's cap. Those who don't know, Barb is Doug's wife. Barb is in the back of the room there. None of those women are Barb. So what can you say? But we continue now to work with this group of hyperscalers, right? This work is extending, it's blowing up. We're now funded, or will be shortly, to develop an interactive training that we're now talking with ASCC about, working with them to help adopt it. But it's going to be, so Doug will have an opportunity to stop just sitting at a board and take it into the internet. Something modern for us, Doug. And then we're also working on a very large outline of a study that's to build a rigorous database that will be open source to help train these AI models, right? Everybody's trying to do this, and we got little bits and pieces of information that's not important or you can't even trust. So this idea is to create the database open source with rigorously collected data that's then validated. So anyone who's doing this kind of work will be able to participate in that. One of the last things, or most recent things we're doing is the Low Carbon Concrete Task Force. This is with Davies and Crooks, funded by ClimateWorks again. Lots of articles, case studies generated, an impactful website. I think that's accurate. And they're providing resources to support low carbon concrete. So this is very, very good. And so wrapping it up, I think we could say, yes, Doug is sustainable. Here he is at his first project, revisiting it, and he was out there as a resident engineer. And, you know, in working with Doug and seeing all of the authors on all of these papers, and those people are now leaders in this industry and future leaders. That's the sustainability and the legacy of Doug Hooton. And on top of that, he's actually a fairly decent guy. And we also decided, depending on how things go down south, we know it's his cellar we're going to hide out in because it's really stocked well with some very, very good wines. So thank you very much.